some of the first enterprises to invest in geospatial systems and data were companies that were able to afford it.
Today we are with Shannon from Angus GeoSolutions from Canada. He's going to talk to us about this changing paradigm of enterprise GIS, especially when it comes to integrating sensors and real-time data, and how do we make that change happen. Dan, welcome to the show. So, can you give a brief, Dan, on the traditional enterprise GIS setups in utilities, how they are, and why there is a need to change it?
Okay. Well, some of the first enterprises to invest in geospatial systems and data were companies that were able to afford it. It was initially a very expensive technology because it was so new. The hardware and software requirements were rather intensive, and so that led the early adopters to usually to be utilities, large government, people that had distributed assets they needed to manage, and budgets that could justify the investment. And because those investments often were driven initially for labor savings within engineering and design operations, it tends to be that most utilities, and certainly within telecom and my experience other utilities as well, invested in traditional GIS systems from an engineering-centric point of view. So those systems were designed to be basically manage those assets as a physical asset that would be tracked at a specific point in time. There were intentions, I think, early on that GIS systems would serve an entire organization. People saw the potential. But by the time that they were built and implemented, because the people who had made the initial business cases and provided the initial funding were the ones that drove the design criteria. So not only were the applications built around engineering, the data-based design was centered around their requirements, and the data that was collected and what data was not collected was also informed by those initial stakeholders. As a result, those systems really don't suit themselves for the new way people are using GIS. The business community has taken GIS, and certainly rather than being part of the back office where it's part of a cost center, it's helping them reach the customers. They understand its value in terms of connecting themselves and their services to the customers. And it results in a very different kind of requirement for GIS, especially as we start to see the technologies evolve that change the kind of data that we're looking at and the kind of interactions we want with our geospatial systems.
When this application paradigm moves from the engineering department to the whole enterprise, I think there are new requirements like more analytic-based information, more of decision-making information as the need. So, how are the utilities preparing to this new paradigm of moving towards more analytics and more information-based decision making?
Well, what we're seeing with our clients is that they're the ones that are moving forward are recognizing that they need to interact with data over a period of time. Instead of a GIS system telling them what is at a state and time, they need to know what is happening, what has happened, and hopefully what will happen. And so that requires a stream of data that is collected over time that they can analyze. And so they're getting this data from a number of sources, and the other key element is that data is coming to them much more rapidly, and it's not waiting for a traditional update cycle that might see as-built records coming from the field that could take weeks or possibly even months to be updated in the system. So not only is more data being considered, the update cycle and the workflows that support that are coming closer to near and to real time. So that puts a whole new stress on systems, especially when you look at things like smart grid, as some of our clients are. That is so critical that they have a current operating picture, that they can't afford to have that data flow manual. They can't afford it to be lagging behind, because they need to be able to make decisions that are immediate, that are based on that moment's performance of their network.
So when you mean by sensors in the network, what kind of sensors are you talking about? Are you talking about individual electric poles, or you are talking about a distribution point, or what kind of sensors are you really talking about here?
Well, in the truest form, sensors certainly within the electrical network being AMI applications with automatic meter infrastructure, as well as just sensors within pieces of equipment such as transformers that give back a lot of information to the users about data and the performance of the network. And then some other companies have radio sensors that are just providing some basic capacity and use information back as well. But we can take any of that information, and for a lot of our clients, they appreciate having the opportunity to see that within their GIS system. So rather than being just a straight asset management system, it's really supporting their day-to-day operations in a very contemporary way. And so for us, the impact has certainly been on performance, because you're managing so much more data that's coming at you very quickly. And ironically, you need to distill that down to actionable insights for the customer. So even though you're dealing with exponentially more information, the opposite is true for the client wanting to basically see less information. They want to see more targeted, relevant information that they can then make a quick and intelligent decision on. So there's a real challenge there to take more data and condense it, in a sense, even more. And so that's affected how we design our database, very open. And I have a professor of mine who talks about database design that says, design for performance, don't tune for performance. And I think it's even more critical now that we design our databases to perform well, because they're going to have to rely more on real-time queries and real-time information rather than analytics that, for the most part, with GIS systems has been pulled offline, extracted from the system, and then analyzed over a period of time to provide a result to tell you, the users, what has happened. Because people want to know what has happened, that still will happen, but people need to also know what is happening now. And that requires that real focus on smart database design.
So take the current situation of the GIS systems. They were and are meant to be designed. They are traditionally designed to take offline information from as-built drawings or on-field inspections kind of stuff, having very limited number of fields, having very limited number of inputs. But with this real-time data being pushed in continuously, how is the GIS model actually changing itself?
Well, I think it's important to understand how the data is going to be used, so the table structures and indexes can be built in a way that is going to reflect how the data is going to be used, rather than having it fit sort of just a logical model of how things are. A lot of data models are coherent, but they're reflective of how we sort of look at things as being organized, but that doesn't necessarily reflect how they're going to be queried, used, and managed. So there's a slight difference there in terms of the data structure and design. I think with some of the new capabilities of hardware, such as Exadata equipment, things that will manage big and large unstructured data sets, that there's an opportunity to expect that we can manage all sorts of data very quickly, but it doesn't negate the importance of smart design with the data. Keeping data that's used a lot in memory probably solves a lot of that issues for our clients.
Coming to the database, the software systems itself, let us take a traditional enterprise GIS, having an Oracle database, on top of it an ArcSD kind of a system, and on top of it an ArcGIS interface running. When you talk about this flexible and modular database, what are those actual database components? Is it an Oracle database, or can you give some systems that are already Oracle foolproof for these kind of scenarios?
Right. I mean, there's all sorts of approaches that can work. For us, we found most success working with an Oracle data structure. Now, we can work with and write into any of these other main GIS systems. So we play nicely with other systems, but in terms of that mission critical data that is being depended upon and relied upon for information decision making at the moment, we work with that data in Oracle. And we also take advantage of common information models, like for the standard information model, or SIM, for the electrical networks. regardless of what a company's design or asset GIS may be, will load it in and transform it into that common information model. It improves the performance in terms of managing the network and tracing network, and it also allows us to interact with and integrate with other data sources that are coming in a standard structure, because we're using that standard model. So that's been our approach.
Okay, but that's the data part of it. Now you again spoke on having real-time dashboards on what's happening in real time. How does the front-end UI happen of integrating this Oracle-based data onto the front end?
Sure.
What kind of tools are you using for this kind of a scenario?
Well, we're working with the Oracle Map Builder tool. So, but really at the core of it is a web services architecture, so that while we do a presentation map that's built on the Oracle Map Builder, by using a web services architecture, our clients can use other tools, because there's really very few businesses that don't have some investment already in different technologies or other user requirements that may lead them down to using different tools at the front end. So as long as we're using a consistent architecture on the first tier, and we present that web services architecture, people can leverage our applications and our tools and present them in other front-end user applications. But our web builder is configurable, and the key for us is to be able to deploy solutions to users that are tailored, so they see the data, they have the functionality, and they have the environment that's specifically suited for their task. So it provides the advantage of a customized application without the cost of deploying another application. You're simply configuring for another way of leveraging the data and the web services that are available to them.
So has Angus already developed a customized solution that can be provided to multiple customers? Are you doing every time from scratch kind of a scenario?
We really find it's very important for us to focus on a modular approach, so that there's core functionality that's going to be useful across different industries, so that we can build upon. And then there's configuration points that are useful within that industry that we can reuse among different clients within that industry. Now we understand that everybody's got different ways they use their data, so there's always some configuration that goes on. But the more modular we can build our software, the quicker it is to deploy, and the lower the cost is to the consumer by having modular components of our suite that are be able to be reused. The other reason we want to do that is that it allows us to upgrade that, and then that becomes available to our clients.
What is the name of the suite that you offer to the clients?
We call it Go 360, because we like to cover all 360 degrees of an organization, and we don't come in to necessarily replace somebody's GIS, but we certainly see ourselves as an enterprise solution that can fill a lot of gaps that are there, and really started to let people to leverage that across the organization.
So the license-based is server-based, seat-based, or it's a subscription model? How do you provide this?
Right, it is based on seats, and we do have a server component for the application. What we do is, because we're based our application on HTML5, it runs in the browser on multiple operating systems and multiple hardware devices in the field and in the office. And so that allows us for very rapidly scalable deployments. And so it allows people to subscribe as their use of that application grows across different groups and different departments. And so we have a pretty flexible pricing model that accounts for making it affordable for small companies. And by not having client software to install and to manage, it lowers the cost of ownership. It lowers their call on their IT resources, lowers the call on their hardware resources, and certainly makes managing of the application and who's using it a lot simpler when you're managing user accounts rather than managing installed client software base.
So it's an on-premise model, or are you also providing a private cloud or a public cloud model?
We host for some clients within a data center. So it's not a cloud, it's a controlled environment data center. But for the majority of our clients, they like to host the data themselves. That allows for more easy and immediate integration with some of their internal data sets. And for a lot of our clients, they do have IT infrastructure and they do like to handle that internally. But we do have clients that have chosen to have us provide the hosting through a partnership we have with the Internet Data Center provider that makes sure that they get the security and the performance they need and keeps them from having to worry about managing that infrastructure.
Okay, so then the pricing is integrated, the pricing varies accordingly, right?
That's right. Well, that's to some extent integrated. To some extent it's simply modular, that if they need hosting, that'll kind of depend on how much data that they're hosting and how much bandwidth requirements they have. And that's essentially just an added cost that they can then evaluate whether that is a value to them given their structure.
Okay, great, Dan. Thank you for your valuable inputs today.
It was very nice talking to Harsha.
Thank you.
Appreciate it.